Mic on.
Graphs of exponential and log functions. So during calculus, we're going to be spending a lot of time talking about exponential functions and log functions, and we need to have some idea of what these functions look like. Okay, so here's a graph of an exponential function, and this is the function y equals 3 to the x. And this is a very typical exponential function. All exponential functions have this basic shape, where one side shoots up, going off to infinity, and the other side converges to 0 as we go in the other direction. Okay, all exponential functions have this same basic shape. Now there's a slight variation between the two. For instance, if we also graph y equals 2 to the x, we see that it has the same basic shape. It's just because the base of the exponential is smaller, it takes longer to rise. So instead of going up as steep as 3 to the x, it comes out a little bit wider because it's taking its time to get into the high numbers. And we can see the same thing if we graph y equals 5 to the x. Since that has a bigger base, we would expect that one to come up inside here and rise even faster than 3 to the x. And we see that is in fact the case. That 5 to the x shown here in green rises very quickly compared to 3 to the x or 2 to the x. Now there's one more exponential function that I want to show you, and that's base e. So e to the x, and we'll be using e as the base of our exponential functions and log functions most of the time in calculus, so it ends up being really important. But e is approximately equal to 2.78. So it's going to be somewhere between 2 and 3, so we should expect it to be somewhere in here. Now 2.78 is closer to 3 than it is to 2, so it should stay closer to 3 to the x. And so let's see if that is in fact the case. Okay, and now we see e to the x is the one here in purple, and it is landing between 3 to the x, which is red, and 2 to the x, which is blue, and it is closer to the 3 to the x, just like we expected it to be. For all of the exponential functions that are shown here, we see that on the right side, as x gets bigger and bigger and bigger, as we move further in this direction, we see that this function's going off to infinity. And exponential functions actually grow really, really quickly, so they go off to infinity really fast. But as we move in the positive direction, all of these are going to go off to infinity. And as we move in the negative direction, all of these get closer and closer to 0. And we would say, using calculus terminology, we would say that these all converge to 0 as we head out towards negative infinity. Okay. Now there is one more thing. So all of these had bases that were larger than 1. Well, what happens if we have a base that's less than 1? Okay, so what we have here over on the right is here for comparison. This is 3 to the x. Over here on the left is 1/3 to the x. And 1/3 is the reciprocal of 3. And we notice the effect that that has is that it makes it a mirror image. So these two images are exactly the same, except for 1/3 to the x is flipped. So we are going off to infinity when we head to the left, and we're going to 0 when we head to the right. Okay, so anytime the base is less than 1, what it's going to do is just going to flip it left and right, so that the infinity is on the left and the 0 is on the right. And it is a mirror image of its reciprocal that goes the other way. Okay, so what we have here is a graph of natural log of x. So natural log of x is log base e. And this is the general shape of pretty much any log function. We have going out to the right, it's rising, but it's doing it very, very slowly. So it's pretty flat. The further we go out, though, this will continue rising forever. So as we continue going to the right, we can make it as high as we want. It just takes a long time to get there. As we go to the left, we notice that we have an asymptote at 0. And all log functions have this asymptote at 0. And so as we approach 0, we're going to go down to negative infinity. The one pictured here is natural log of x, which is base e. But all log functions have the same basic shape. Some of them rise a little bit faster. Some of them rise a little bit slower. But overall, this is the shape. Over to the right, it's pretty flat, but rising. And at 0, we have the asymptote going down.